ahead and start when you're ready. I'm going to go to the restroom.
Okay. Now we're going to start on our variable section. It starts in chapter 2 of the Pearson book. A variable is any letter, like the infamous Mr. X, a symbol, like the Greek letter beta, a picture like a smiling face, or a phrase, choo-choo Martin. I don't know, anything. The next thing to talk about is a coefficient. Usually a variable isn't by itself. It's got a number in front of it. The number in front of it is called the coefficient. And this number is multiplied to the variable. So if I write 2x, that's the same thing as writing 2 times x. There's only one thing more to talk about in this section, and that is the constant. And this is a plain number by itself. So if we have our 2x and we add 4 to it, the 4 is a constant. So let's take us a little variable expression and see if we can identify the parts of it. So here we go. R is short for variables. The variables is all the letters. This doesn't mean X, Y, and Z. They're part of it, but they're not all of it. To be a separate variable, they have to look different. So we've got an X squared here. We've got an X. They look different, so they're different. We've got an XY, which is different from the Y, which is different from Y squared. We've got the Z, and that's all of our variables. The coefficients are the ones that come before the letters. So we've got 4, 2, 3, 7, and you can put the minus sign there or not. The book doesn't specify, so either way, I'm happy with it. This one doesn't have a number in front of it, but it's understood that there's a number there. If there's no number in front of it, it's always understood that the coefficient's 1. So the number in front of the Z is 3, and an 8 is just by itself, so it's going to be our constant. Rewrite that. 8. So that's all about that. The next step is substituting in values. When you know some of the variable amounts. So if we have this expression and they tell us that the x is 2 and the y is 4, we just plug those numbers in where those letters occur. So if this is 3, remember this times the 2, plus 2 times the 4, and then we have the 4 on the end added to it. So 3 times 2 is 6, plus 2 times 4 is 8, plus 4 is 14, plus 4 is 18. Notice we're still using our Sally rules, but please excuse my doing Sally, parentheses, exponent, multiply, divide, add, subtract. That never changes. We ever get to this monster called simplify. This doesn't mean you're going to end up with an actual number value. Sometimes it can, but it doesn't always. Simplify just means it make it look simpler. So you're going to have something like this. You're going to follow your same Sally rules. And then this last step, the add and subtract, is called combine like terms. Like terms means it has to have the exact same variable, or it just has to be a constant. So here we've got a 2x and a 3x. So we can combine those and have 2 plus the 3. The sign in front of the variable is the one that you use. So 2 plus 3 is 5x. There's only one y term, so we bring that down. And then only one constant. So this, even though it still looks ugly, is the simplified form. They get bigger. The more you have to do with the Sally rules, the longer these can be. But they're just as easy. So here's a little longer one. You cannot add or subtract a variable and a constant. So in this instance, you're just going to have to distribute this 4 through the parentheses. So you have 4 times the x plus 4 times the 3 is 12 times 2x plus 5. Now we're down to the add and subtract step, combine like terms. So we look for the exact same kind of thing. We have 2x terms. So 4 plus 2 is 6x. 12 plus 5 is 17. So this is the simplified form. Notice you have this 2x squared plus a 3x. They both have x's in it, but the terms are different because this is a square and this doesn't. This does not equal 6x to the third. And I'm going to erase it really quick once you get the idea. Another important thing to know is when you add and subtract the same variable, like a 3x and a 4x, that gives you 7x. The power on the x stays the same. So if you start out with a plain x, you're going to end out with a plain x. This is different. The adding and subtracting is different from multiplying and dividing variables because when you multiply and divide, you will change the power of the x. So if you have 3x times another x, this is going to be 3x squared. There's also another number that they could put here that they never do. Anytime you have a plain variable, the power of it is 1. So 3x to the first times another first is called the exponent power rule. I believe they call it different things in different books. And then they have the straight power rule, which says if you have something raised to a power, let me take the coefficient away so it's clear, and you raise it to another power, the whole thing, you're going to end up with x to the 8. If you have two separate variable terms that you're multiplying, that's when you add the exponents. If you have one variable term to a power and you're raising it to another power, you multiply the exponents to get your final answer. And dividing works similarly. If you have something like this, the easiest way at the beginning is to visually see this. This is the same as saying 3 times x times x times x times x times x over 3x is x times x times x. Since it's all multiplying, you can cancel out anything that's the same in top and bottom. So we've got 1x, another x, and another x. So we're left with 3 times x equals 3x squared. Another way to look at this is you've got the 3, and now you're just dealing with these variable terms. You take the top exponent and subtract from it the bottom exponent, and you get the same answer. This top one is probably more understandable at this level for you. Eventually you're going to learn this rule here. We're going to do another simplify. It's a little long. Now we have a whole bunch of things to do. We follow our same rules. Parentheses, we can't add and subtract a variable and constant, so this is actually going to be multiply. We don't have any exponents to deal with here, besides what are just already there. So it's multiply and divide. So the first thing we have to do is this multiplication, because it comes first on the left. So we're going to do x times x, that's x to the first, times x to the first, is going to be x squared. Minus x times minus 3 is minus 3x. Bring everything else down. So the next thing we can do is this division. Divided by 4 is 3. X to the 5th divided by x to the 4th gives us just the x. I'll draw that out here. Cancel out everything that's the same. You're left with the 1x, and then 12 divided by 4 is the 3x. So that's where I got. Where to get this one? We're not done yet. Almost. So we've got 4x, 3x, 7. So we've got two x squared terms. All we're left with is add and subtracting left to right. So 4x plus a 1x is a 5x squared. Then we've got the a minus 3 and a plus 3x. That just cancels out, that'll be 0. And we have minus 7 left over. So that's your final simplified answer. It gets more fun. We just solve. To solve, we're going to go through this first simplification step. That's the first thing you do every time. And the second thing you do is move things across the equal sign. And this is one of the trickiest things to remember. When you're simplifying, just use straight math. If it says 4x plus 5x, that's 9x. When you get to the solving part, solving part, you're going to move all the x terms to one side of the equal signs and all constants to the other side. The way to do this is by using the opposite math function. This is what we did with the Pythagorean theorem. You'll see in a minute. So we're looking for the side B. So let's see. I think that'll work out evenly. No, let's make it more. Now, we'll start here. First thing you do is simplify. Well, how do you know it's simple? Simplify means you have one of each kind of term. So here we have an x term and a constant. On the other side, we have an x term and a constant. So both sides are simplified. So we don't have to worry about number 1 in this case. All we have to worry about is the number 2, moving things across the equal sign. It doesn't matter which one you pick to move to what side, it'll still work out. I'm going to go ahead and move this 4x. So it's a positive 4x. To move it across the equal signs, I'm going to have to subtract it. So this term's gone. So I'm left with 3x plus 23 equals a minus 7. Now I have this x and a 23. I don't want that. I want 23 over there with its other buddy constant. So it's a positive 23, so I'm going to have to subtract it. And what I do on one side of the equal signs, I have to do on the other. So this one's gone. So I'm left with 3x equals a minus 30. And the last thing you do is divide out the 3 on both sides. So I get x as a negative 10. If you ever want to check the answer you have, you just plug this number in for all the x's in the first problem, and if this side equals that side at the end, you know you've got it right. So let's do a little more difficult one. Actually, there's one thing I want to talk about. If you ever have a minus sign outside one of these parentheses, like we have a minus 4, this minus is like a bratty little kid that you wish you could dump somewhere, but you have to take it with you. So you're going to have to times this whole thing through this parentheses, because you can't add or subtract a variable and constant. So you got a negative 4 times x is negative 4x. A negative 4 times a positive 3 is negative 12. So now we have over here our x term and a constant, so this side simplified. Once you simplify one side, together because it says so. So 12x minus 4. So now I have an x term and a constant, so it's simplified. Now we can start moving things across the equal signs. So notice up here, I did the straight math. If it said to add, I add. If it said subtract, I subtract. Here, we're going to start moving it across the equal signs. So here is where I start doing the opposite thing. I'm going to move this 4. It's a minus 4, so I'm going to do the opposite and add it. And I have to do it over here too to be fair. So this is gone. So I got the negative 12 on this side equals 16x and the minus 4. So I'm going to move this over there now. So negative 4, so I'm going to do the opposite and add it on both sides. So the 4s are gone over here. So I'm left with no room. Negative 8 equals 16x. Yeah, that's all right. The last thing you'll do is divide. So x equals a negative 1/2. X's can be decimals, they can be negative. If it's the right answer, it doesn't matter. It's still fit. It still works. This last step you're doing here is the same thing. The last step you did with the proportions. You cross multiply, then divide what's in front of the x. It's the same thing. We're using all these variable rules to solve these problems. I call this the divorce step, the last one. So the last thing you ever want to do is have to go through a divorce. So that's the last thing you do is divide. Math is just like family dynamics. What you do to one side, you have to do to another. So if you have two kids, you have to give them the same thing or they'll fight. And the last thing you want to do is divorce. So it's all happening. So now we know how to simplify and solve variable equations. And now we go to the recursive word problems. Oh my, I know you hate it. You start out simply with something like 6 plus a number is, where it's 17. And you're just supposed to write it down. Well, anything like the word plus, add to, more than, increase by, that's going to give you the indication to add something. So we got 6 plus a number, we don't know what it is, so we're just going to call it x. Is a special word that means the equal signs. And then 17 is just over by itself. From here, you could solve it if you want. Yes, it can solve. You want the x by itself, it's a positive 6. So you're going to have to subtract on both sides. Get rid of it, so x equals 11. Be careful of the words. Less than and subtracted by or subtracted from. These usually flip the problem around from what you think it is. So if we had 10 less than a number, this isn't 10 subtracted a number. This is, you take a number and you take 10 away from it.